let's take a look at section 7 here of chapter 29. And now that the fetus has been delivered, we're going to be taking a look at what happens to that neonate, which, remember, this is what it's called once it's been delivered, what happens after it has been born. So we're going to focus mainly on respiratory and cardiovascular changes because that's going to be a huge change. But we'll also briefly take a look at some urinary differences and things like that. So first of all, there's your neonate, the definition. It's the term for the fetus after being expelled from the uterus. So let's think about what has been happening in the womb so far and how that fetus is going to be different than a neonate. So first of all, it's not breathing on its own, right? It is getting all of its gas from the placenta. So all of the respiratory gas, the oxygen and the carbon dioxide, has been given to it by the placenta. So those lungs are completely fluid filled. They're not inflated because they're not needed. So that actually leads to differences in the heart as well. Remember how we talked about that way back in that other chapter at the very beginning of the semester, like the foramen ovale, the ductus arteriosus, all of those structures that were allowing the blood to bypass the lungs, the majority of it to bypass the lungs because of it. Another thing is that the fetus isn't having to eat. It doesn't have to eat, obtain its nutrients, and it doesn't have to digest its own nutrients. So that's another thing that's going to be a little bit different, is that it's going to have to eat on its own, and it's going to have to digest its own food right now. Because remember, the way that it was getting nutrients, it was already broken down, and it was getting it from the placenta. Another thing is waste excretion as well, regulating body temperature. It's been bathed in this amniotic fluid that's helping regulate body temperature. So once the fetus is born, that neonate's going to have to learn how to regulate its own body temperature. So let's first take a look at respiratory changes in the neonate, and then that is actually going to lead us to cardiovascular changes, because what happens there with taking that first breath is going to really lead to those changes. So again, this mentions that the fetal lungs are not fully inflated prior to birth. We already know that. It usually is going to take its first breaths within 10 seconds of birth. So some of the things that are going to stimulate that first breath, and it's going to usually be a powerful one, is that the fact that we have cut the umbilical cord, right? We have clamped it off and have cut it. And remember, that's been the source of gas exchange so far. That's how it's been able to get in oxygen, but also get rid of carbon dioxide. At this point, when we cut it and clamp it, it's not able to get rid of carbon dioxide. So think about it. It is increasing those CO2 levels. Remember what happens in adults when CO2 levels increase in our bloodstream? We are going to increase our respiratory rate, right? Because we are going to try and get rid of the carbon dioxide. So they believe scientists believe that this is one thing that's going to stimulate that breath, that first breath in the neonate is going to be those increasing carbon dioxide levels that, of course, are going to cause a decrease in pH levels. Another thing they believe is temperature changes, that newborn is going to undergo a drop in body temperature. If you think about it, it's been in this nice warm womb for 9 months, and it's put out in this really cold environment. If you think about 98.6 degrees in here compared to what, 70 something out in the room. So that's also going to kind of stimulate it. It also goes through this mechanical stimulation through that whole delivery process, and also after birth as well. If you've ever had a child, you know exactly what they're doing after birth. No, the doctor doesn't slap it, but the nurses do go in and stimulate it quite a bit. Not only do they go in and take all of that liquid that's covering it off because of body temperature regulation, but they are also going in and mechanically stimulating that newborn in order to get it going as well. So the lungs are going to inflate with that first breath, and hopefully it is going to stay open because surfactant is being produced. So surfactant is going to keep the alveoli patent or open. If a newborn is born earlier than 28 weeks, so usually surfactant is produced right around the 28-week mark. So if there is a premature baby that's born before 28 weeks, then a lot of times the surfactant is not enough, and they have to be put on a ventilator because of it. They are going to have that respiratory distress that can occur with premature infants. So now let's take a look at circulatory changes here in the neonate. Remember, prior to birth, we were going through and blood was being shunted away from the non-functional lungs. And you can see those adaptations, those structures there. There's that foramen ovale was one of them, and also that ductus arteriosus, that connection between that aorta and the pulmonary trunk, showing that detour right there. Well, there's no longer need. Now we need to make sure that we get blood to the lungs because that's where gas exchange happens. So when neonates have that first breath, they are going to have a drop in pulmonary resistance, which is actually going to cause a dilation in those pulmonary arteries. What this does is it's going to create a pressure difference in the heart. You're going to have a decreased pressure on the right side, and then the pressure is going to be greater on the left side. So because of this whole difference, but also specifically between the atria, the right and left atria, that's what's going to help shut off that foramen ovale. And also that ductus arteriosus is going to become a ligament after that as well. It's going to close off. So this is what's showing it there. It becomes the fossa ovalis and then the ligamentum arteriosum. And of course, remember that the umbilical arteries and veins are going to become these different ligaments as well. Everything that we went through are going to be modified and changed because of the circulatory changes. So the other things the book really doesn't go into is some of the differences with urinary and body temperature regulation, which I want to talk about a little bit. But with urinary, neonates, yeah, they can produce their own urine, but the difference between neonates and older kids and adults, I'm not exactly sure what the point is, what age they start this, but neonates cannot undergo, their bodies cannot do that whole countercurrent multiplication, which was a way to concentrate urine, a way for us to conserve water. So if you think about it, if you've ever had a baby before, they are urinating constantly, and they are going to tend to be more prone to dehydration because of it. So that's why they do need to be fed quite often to keep them hydrated. But, and again, I don't know exactly what age that whole countercurrent mechanism kicks in, but that's one difference there. Another thing is that body temperature regulation. So specifically when they get cold, the infants cannot shiver. They're not able to shiver. So that's why they tell you when you do have that neonate, that young baby, that you need to make sure that they are wrapped up constantly because they are not able to warm themselves up that way. So that's another kind of difference there.